I welcome you all for this lecture series on artificial intelligence and machine learning. In this lecture, we'll see how the gradient descent techniques is used in AIML, that is artificial intelligence and machine learning. This gradient descent, that is, we are calling it as GD, gradient descent, is a fundamental optimization technique in AI and machine learning that is iteratively updates model parameters to minimize the loss function, covering towards optimal solutions. By calculating gradients of the loss function with respect to model parameters, the descent adjusts the parameters in the direction of negative gradient, reducing the loss. Variants like stochastic gradient descent, that is SGD, and mini batch gradient descent offer flexibility and scalability for large data sets. GD is widely used in training neural networks, linear regression, and logistic regression, making it a crucial component of many AI and ML applications. We'll see one by one. And this AI ML, how it is used in the, that is this gradient descent, how it is being used in the AI ML. We'll see. Artificial intelligence, all you know, it is the broad field concerned with the building machines or systems that can perform tasks typically requiring human intelligence, such as perception, reasoning, learning, and decision making. Within AI, machine learning, that is ML, is a specialized or a subfield focus on developing algorithms that allow system to learn from data without being explicitly programmed. Gradient descent comes into play as the foundational optimization technique with the machine learning. It is used to adjust the parameters of machine learning models, what are all the models like weights and biases, to minimize the error between the predicted output and the actual output. Essentially, gradient descent enables the learning process in machine learning, and since ML powers much of modern AI, it becomes a vital component of AI itself. Next, how it is used in the AI model. This gradient descent is used in AI models. Gradient descent plays a critical role in how AI models learn and improve. During training, AI model generates predictions and compares them to actual results using loss function. This function measures how far off the model's predictions are. Gradient descent computes the gradient or slope of the loss function with respect to each model parameter and uses this information to adjust those parameters in the direction that reduces the error. These small, repeated adjustments allow the model to become more accurate over time. Whether it's a linear regression model, a decision tree, or a complex neural network, gradient descent is the mechanism through which the model optimizes itself to perform better. Next, the learning. This we are calling it as the optimization is equal to optimization. At the core of AI, in the concepts of learning and in mathematical terms, learning is essentially an optimization problem. AI systems need to find the best configuration of internal parameters that minimizes the difference between the model's predictions and the true outcomes. Gradient descent is the engine that drives the optimization. By taking steps proportional to the negative of the gradient, what will happen? The algorithm ensures that each iteration leads to a lower value of the loss function. This gradual descent down the slope of surface enables the AI system to converge to an optimal or near optimal solution. Thus, gradient descent translates the abstract goal of learning into concrete optimization process that machines can execute efficiently. Next, this is the example of AI applications. If you are taking the computer vision, how the gradient descent is used. The power of gradient descent can be seen in a wide range of real-world applications. AI application in computer vision. For example, the convolution neural network (CNN) use gradient descent to learn filters that detect features like edges, shapes, and objects. Say, for example, cats versus dogs, etc. In natural language processing, if you are taking models like BERT and GPT are trained using gradient descent to understand and generate human language by adjusting billions of parameters. In speech recognition, if you are taking the speech recognition, gradient descent helps learn mapping from raw audio signal to textual transcripts. In robotics and reinforcement learning, gradient based optimization is used to improve decision policies over time. In all these applications, gradient descent is the algorithm that allows a system to learn parameters from where? From the data, adjust itself, and perform tasks that would otherwise require human intelligence. And AI applications, the of gradient descent computes the computer vision trains CNN to recognize images. Say, for example, cats versus the dogs, as I've said. Next, how the equation, what type of equation we are using in AI context. The equation in the realm of artificial intelligence, particularly in learning-based systems such as neural network, it is essential for models to evolve by adjusting their internal parameters as they are exposed to more data. This constant refinement is governed by the formula theta is equal to theta minus alpha into dou j by dou theta, which stands at the core of machine learning. This is very, very important formula. This mathematical rule enables a model to minimize its errors and improve its decision making capability over time. By systematically updating its parameters, the AI system adopts and performs tasks like classification, prediction, and decision making with increasing accuracy. So these parameters we'll see one by one. First, theta. This theta we are calling it as the model parameter in AI. The artificial intelligence models in artificial intelligence model, particularly neural network, the theta represent denotes the internal parameter of the model, primarily the weights and biases. These parameters are fundamental building blocks that determines how the input data is processed to produce an output. At the beginning of training, these parameters are usually initialized randomly. As training progresses, what will happen? They are refined based on the data and desired output. The goal of learning is to adjust these values so that model can effectively map inputs to correct outputs, such as classifying an image or translating a sentence. If these parameters remain static or are not updated, the model cannot learn from the data or improve its performance. Next, doje by this do data, this we are calling it as the gradient of loss function. Gradient of loss function. The term doje do data represents the gradient of the loss function with respect to the model parameters. This gradient indicates how sensitive the error, that is, or losses, is to changes in parameters. The loss function denoted as j of theta quantifies the difference between the model's prediction and the actual outcome. A higher value of j implies that model is performing poorly. By computing the gradient, we gain insight into how adjust each parameter theta in a way that would reduce the error. This adjustment is central to learning process as it guides the model in right direction to minimize its mistakes and improve its predictions. Next, in this formula, we should know about this alpha. What is alpha? Alpha, we can call it as the learning rate. The learning rate represented by alpha, it is a crucial hyperparameter in the training of process of AI models. It controls the size of the step taken in the direction indicated by the gradient during parameter updates. If the learning rate is set to too high, the model may overshoot the optimal values of parameters, causing the training to diverge or oscillate. On the other hand, if alpha is too low, the model may take an impractically long time to converge or may get stuck in local minima. Therefore, the selecting an appropriate learning rate is essential for effective and efficient training, ensuring that model makes meaningful progress during each iteration. Next, role in iteration, role in training AI model. The updates rule theta is equal to, what is the formula here? Theta is equal to theta minus alpha into dou j by dou theta. Here, the update rule theta is equal to theta minus alpha and tau j by theta is not just applied just once but repeated millions of times during the training phase of AI model. Each time the model processes a new data point or batch of data, it computes the gradient and adjusts its parameters slightly based on that feedback. This repetitive process is what allows the model to gradually learn complex patterns and make accurate predictions. Whether it's recognizing spoken words is a voice assistance, identifying objects in a self driving cars environment, or suggesting movies in recommendation system, this update mechanism is constantly at work refining the model's understanding of data. Okay, coming into the summary, why it matters for AI. This theta is equal to theta minus alpha dou j by tau theta. Why it matters? Gradient descent matters. The formula theta is equal to theta minus alpha into dou j by dou theta is the foundation of learning process in AI system. It enables machines to improve systematically by reducing their prediction errors in a controlled manner. Without this method of updating parameters, AI system would remain static and incapable of learning that is from the new information. This formula bridges the gap between raw data and intelligent behavior, empowering models to make better decisions over time. By repeatedly applying this update rule, the system incrementally reduces its error and owns its ability to perform complex tasks with greater precision. And all you know that the gradient descent is not just linked to artificial intelligence, but it is one of the core mechanism that makes AI system functional and effective. At the heart of AI model, it is the ability to learn from data, that is to recognize patterns, make decisions, and improve over time. Gradient descent makes this possible by providing a systematic way to optimize the model's performance. It does so by minimizing the loss function, which measures the gap between model's predictions and actual outcomes. Through repeated updates, the algorithm adjusts the model's internal parameters like weights in neural networks in small steps, always moving in the direction that reduces the error. This iterative process of tuning parameters is what enables the model to become more accurate and intelligent with each cycle of learning. And you know that without gradient descent or similar optimization technique, AI model would have no clear method for self-correction or improvement. They would make random or statistic predictions with no capability to adopt based on experience or data. In this way, the gradient descent is not just a tool with AI, it's a foundational principle that empowers AI to learn, evolve, and perform tasks that simulate human intelligence. Hope everyone understood about how the gradient descent algorithm techniques used in the AIML techniques. The remaining things we'll discuss in the next lecture. Thank you.